Hello, this is Dr. Christy Patton-Lukes, a chemical engineering professor at Missouri S&T. We are going to somewhat wrap up our discussion of curve fitting by looking at Excel's LinEst function. So we've started by deriving a system of linear equations. In this case, what you're seeing here is the solution to a linear equation. And we have these formulas here. And the thing is that most of the equations that we're going to do are fairly common. And so Excel actually knows how to do these also. And we've already looked at trend line, which is nice because it's very visual. And we looked at the regression tool, which is nice because then it gives us usable numbers. But the disadvantage of this is that every time if I change my data in any way, I have to rerun the regression tool. So I'd like something that's sort of like halfway between these two. And the LinEst function is one that's very useful for this. So what I'm saying is LinEst. So it's line estimator, but it can be for more than just straight lines. And if you want to use this, I'm going to be in this case looking at a straight line fit, and I want there to be two parameters I'm finding, right? The slope and the intercept. And so therefore I want to highlight two cells and make sure they are going across and begin typing. So this is going to be an array or a matrix type function. So equals line estimator, LinEst, okay? And then highlight your known y's, comma, highlight your known x's. And then you can also add here if you need the constant to be 0 or, which for our purposes just means that I would need to calculate the slope with that. And if I want to show statistical information, and I'm just going to just get my slope and intercept. And I will do a Control-Shift-Enter. So again, this is an array tool, so I have to do Control plus Shift plus Enter. And it gives me my slope and my intercept, which then would allow me to come in and do calculations fairly easily with one step instead of two here. Okay. Let's look at the second example. Here we were doing a third order polynomial, and a third order polynomial has 4 constants. So let's highlight a group of 4 cells so that I can list my 4 constants. In this case, I want temperature to be my known y, and my known x's will be my variables to the various powers. Close the parenthesis, Control-Shift-Enter, and I do indeed get those constants. So this is for the w cubed, this is for w squared, this is for the w, and this is for my constant term. And so I do have all of those coefficients in one step. And better yet, if I were to change any of these numbers, so let's change this to say 25, what you see is it does indeed recalculate my number. So that's an advantage over the regression, but it still gives me all of the constants in a usable form. Now you can explore and read on your own if you wish. You actually can do this without having to create these additional columns. But the notation for that is complex, and you're not likely to use it often enough to remember it when you need it. So I'm not going to discuss that. I also, though, want to point out that any equation that you are able to change into a linear form. So let's say you had y equals the power law equation, ax to the b power. And let me make this bigger so we can see that. I can take the log of both sides and equals, and using laws of logarithms find that this is this. And so I could set up columns where I had log of x and log of y, and then the slope would be my b, and the intercept would be my log of a. So I can trick data for many, many other types of equations into this form. All I need is that each piece that is added together has a column of data in order to use this approach. So this concludes this lesson. In our next set of lessons, we will be looking at doing interpolation. Thank you very much for your time.